Hey gang, it's Will from Tested.
And Sean as a guest.
Also from Tested.
Yes.
You are a regular 3D printing columnist.
That is true. That is true.
And you've been testing out something that is new to us.
Yes, I got my hands on an Ultimaker 2, which I was super excited about. I was at the 3D print show in New York. There's actually 2 print shows, and I was at both of those and talked to Ultimaker, and they were kind enough to let us borrow one for a while to play with.
So you've had this for about the last month now, I think.
Yeah.
And you've been putting it through the paces. So just so people know, if they don't read the site, they may not know who you are. But you were an Inventern winner.
Yeah.
And before that, you did a lot of 3D printing stuff. You did your degree in 3D printing stuff, and you built this gorgeous Nautilus.
The Octopod, yes.
The Octopod.
Yes. So I have some experience with it.
You've been printing for a while, with a lot of different technologies and a lot of different devices, right?
So this is basically a high-end Fdm printer. So Fdm is the fused deposition modeling, which uses the filament to squirt out a hot end and lays down thin layers of it until you have a finished model. It's typically what you find for home use.
It's kind of like a hot glue gun that has CNC aspects, and you can move the head and lay down one layer, and then you go up a little bit and lay down another layer, and go up a little bit and lay down another layer.
Exactly.
Now there are other home printers and even higher end printers you can see, like SLS and SLA stuff. We'll talk about that stuff in a little bit.
Yeah.
But the gist. Let's just get to the cut to the chase for people who are interested in a high end 3D printer.
Yeah.
This is a high end FDM printer. It seems like this and MakerBot are kind of the 2 big manufacturers for home use.
If you get into pricier high end ones, I'd say MakerBot and Ultimaker are probably the 2 that pop up most often.
Okay. Yeah. And they use similar technologies but different print heads. We'll do some more direct comparisons later. But do you like this? Is it good?
I do. I like it very much.
Okay.
Yeah. Ultimaker and MakerBot have been around kind of almost the same amount of time. You saw them at Maker Faire a lot early on. And they both started out with kits. And then they evolved into you buy it and it works. So this particular model will do PLA and ABS because it has a heated print bed.
Okay.
It's a glass print bed, so you can remove the plate and to get prints off really easily.
And it's like Pyrex or some borosilicate glass.
It's like exactly. It's like heat resistant, chip proof kind of stuff, and which makes it really nice for getting. Sometimes the prints really get stuck to the bed, and you can put printer tape on it, the blue painter tape like we normally do. You could put the Kapton tape on it if you wanted to.
Okay.
Or their thing is they'll use a glue stick.
Okay.
Which, if you're having adhesion problems, you can put a little glue stick on there and it helps and it just washes off. And then there's also the old standby hairspray, which a lot of people use as well.
So one of the things I've found with PLA especially and heated build platforms is you can get it really, really stuck on there.
Yeah.
Like, do you have to work on this with a putty knife to pop it off, or can you just run it under cool water while it's still warm and it'll pop?
So I just decided to start at as simple as possible. So I just fired it up, nothing on the print bed, and printed some PLA. Now, a lot of PLA printers will have no heated print bed whatsoever. It'll just be a piece of acrylic or maybe glass or something like that. And this one, since it has the heated print bed, it does heat up to about 60 degrees Celsius.
Okay.
Which is not too hot. You're not going to burn yourself on it. Like when ABS is printing, it goes up to 100. And that's hot.
It's boiling.
Yeah. So 60 is not bad. And I found that right on the glass, it stuck without any problem as long as everything was leveled okay. And it came off without any problem. I didn't have anything that really got stuck. Now, I didn't do any test prints that had a gigantic surface area, so that might be a different story. But what happens, I find is when you have the heated print bed, as it starts to cool down, it starts to loosen up the print because you get thermal expansion and that kind of thing. So I didn't have any problems getting it off. But if I did, it's nice that the print bed can come out and you can get if you broke the glass, it's I think $35 to get a replacement. So that's
not too bad.
Yeah.
Who is this printer for? Because we should get this out up front. It's $2,500 shipped to the U.S.
It is $2,500. Yeah.
Which is high end, mid range of the MakerBot range, and way more expensive than things like the PrinterBot Metal Simple or something like that.
Yeah. So as a direct comparison, the MakerBot Replicator 5th generation, which is the current one, I believe that is $2,900.
Okay.
$2,900. So they're comparable. So
similar build volume.
Yes,
like
about the similar print volume resolution. This can go to a higher resolution, and it will also print ABS, which the replicator really can't because of the heated print bed thing.
Oh, so they don't have a heated print bed on a $3,000 printer?
Right. Right. So.
Okay.
So then, when you start to compare it that way, it becomes a little more appealing. Now, the catch on this is that Ultimaker is based in the Netherlands, so there was a support distribution problem like in the past, and frankly, when I went back in time and I bought my Thingomatic, I bought a MakerBot Thingomatic, and I moved on to a MakerBot 2X. My main decision between the two of those, because they both had a kit that were very similar, was that they were based out of the Netherlands, and MakerBot was in the U.S. right here in Brooklyn, which
when you
my
lived in
next
New York,
door,
yeah.
right? So, but now they actually they've teamed with. I think I'm saying this, Fabricate. It's actually FBRC number 8.
Okay, that sounds very hackery, but okay.
Yeah, so Fabricate, but they've partnered with them in the U.S., and apparently Fabricate is now doing their U.S. assembly and distribution and support.
Okay, so you have someplace here you can send it if you need help. You're not completely on your own like you were before.
And they have a really nice supply of parts, so extra parts and stuff. So going back to your original question about why would you get this over, something like the PrinterBot Simple or whatever. Well, obvious things is you get a much bigger print volume, right? You typically get a faster and finer print resolution compared to, say, like the Simple.
So that means you're talking about the vertical slices are smaller.
Yeah.
So you have something that looks less stair-steppy and more like say cast object or something like that. Okay.
Exactly. And obviously you get a big cosmetic thing. I mean, this is just really pretty.
It's a nice looking printer.
Yeah.
I mean, when these side panels are acrylic or something, and they're nice and rigid, and the whole thing, it looks like it's from the future.
It's a really nice looking printer.
Yeah.
And it's very quiet also. Like my printers at home that I'm used to, the stepper motors that drive the whole thing do that singing. Like when you see them set up the bunch of disk drives and play the Imperial March, mine's very singy.
I always say that 3D printers have a song, and each one has a little bit of a different song, and you can change the song by changing the slicer and stuff like that.
This one is by far the quietest I've run across. It is very nice. Now, when it gets a little harder to compare because you're like, well, you can get something like the Dremel printer, which has a very big print bed, and it's like $1,000. Yeah. And it's getting harder for the layman. I think it's getting really hard to decide what the heck should I get. Like, why should I pay $2,500 versus $1,000? And a lot of it is under the hood kind of stuff, like how well are the belts? How tight are the belts, and like what bearings are they using, and like what software is driving it?
What steppers are they using?
Yeah, and all of that stuff can add up to make a big difference. So you could have a printer that seemingly has the exact same specs on paper, and like, why does this print look so much worse than this other one?
Is that going to contribute to the longevity of the printer? Like, because it seems like it's analogous to like buying a table saw, right? You can buy a really cheap $50 table saw that if you use it twice a year will last you for your lifetime. But if you need to use it every day, the motor will burn out in 6 months and you'll be buying another one.
Right. Yeah, and I think that can play into it as well.
Okay.
Like you hear like, the rods that they used weren't hardened, and so the bearings started eating into the rods, or just there's lots of things, and like, so
there's a benefit also to buying something that's been around for a while, so they've figured out all of these problems and have answered them now, rather than figuring them out as you're trying to use your printer.
I think what $2,500 will get you is this. So something like $1,000 printer. They're trying to get more and more to like it just works out of the box. And I don't care what you buy and how it works out of the box. You get 3D printing, the very nature of it, there's going to be a lot of fiddling. There's going to be a lot of failed prints and leveling beds and whatever, no matter what you get.
So the difference is how easy is it to level the bed?
Yeah, like how long it keeps that level, and how easy it is to do it, and and how much you can get away with a little bit of a sloppy level and it's still going to print okay. So I think you get into that, and then you also get into like the nice thing with their slicing software Cura that it comes with. It not only has like the fast, easy draft, normal, ultra high quality settings. You just click the button and print. So you can get started really fast.
Well, it also makes it really easy to place the stuff on the plate, which is hard when you're starting out. You don't remember this, but
because you could get the model actually below the, if you didn't have it laying flat on the bed, it wouldn't print right. So they have a pretty nice software package that makes it easy for beginners to get going. But then it has the advanced tab, which like for more tinkerers who want to like hot rod and fine tune and do a little bit of special stuff. It has all of that stuff really nicely laid out. So I think that's the other thing that kind of gets you is that it gives you a lot more options. So it gives you room to grow.
I mean, that seems like the common thread in why you would buy an expensive printer versus a cheap printer is that this one will grow with you. If you spent $500 on a simple metal kit to see if you were into this, like that seems like a good amount of. It's a lot of money, but it's not too much money that if it doesn't work out, you're bummed.
Right, and
also
it's still
you can
a
turn
great
around
little
and sell
printer.
it.
Yeah, and it's still a great little printer, and there's no reason why not to buy that. It's just it, but you find that your schemes get grander, and it's like I want to build that tank now, and so you need the bigger print bed, and like I personally really like printing with ABS because it has really nice mechanical properties. It's a little flexier than like PLA. It can be trickier to print with, but I like it. So if you decide you want to go into like some funky filaments and stuff like that, so
try some of the stuff with wood and metal embedded.
And the fact that MakerBot and Ultimaker have been around, like I think Ultimaker released their first one in 2009, their first do-it-yourself kit, which they still offer.
Oh, that's awesome.
Which I love.
Yeah, that's right.
And they're still all open source. Even on this, you can get files for this.
So you could conceivably, it wouldn't be cheaper probably, but you could buy all the parts, laser cut the acrylic, do all the stuff yourself, and build your own. That's right.
No, they don't necessarily have a step-by-step on how to do it, but they have all the CAD files and everything and the parts listed, out there.
Well, it also means that if you want to modify your printer later, if you want to take the guts from here and make a bigger enclosure, then you just need to get some more rods and make the bigger enclosure, and you're ready to go.
Yeah.
So one of the things that frustrates me about the low-end printers, and actually our old Replicator 1, was getting one-to-one size registration. So if I needed to make a part that fit precisely someplace, or even something like, say, a Raspberry Pi case that I needed to snap together in exactly the right way so it would nestle in and not wobble, that has traditionally been pretty hard, either because of warping or because the plastic gets a little bit bigger than it or smaller than you expect it to be. Is that still a problem with this? When you're at this level of printer, or
I think it's less. I mean, you're still gonna. I'm even to this day, I'm still fiddling around with what size I need to make a hole to get it to actually fit the screw that I want to put in it. You're still going to run into some issues like that with this, but I'd say it's probably better. I think printing in PLA helps because it doesn't have as much expansion, thermal dynamics as the ABS does.
The ABS actually shrinks over as it cools down.
And the fact that this can do such fine resolution, I think you would see less of that. I have not myself done enough mechanical parts on it to say for sure, but I think that you would be more likely to have less problems.
And it seems like, from looking at the pieces that you've made, it seems like warping is much less of a problem on the first few layers, so you don't have that kind of rocker and camber.
PLA, I printed some pretty big PLA parts, turned out perfect.
Okay.
I had a little glue stick on it, that was it. I did try some ABS. Now the ABS I just started with for fun. I just tried it right on the glass. That didn't work. I knew that wouldn't work. Then I moved on to the glue stick, and I still was having some adhering problems.
I always had really good luck with Kapton and
I love Kapton.
ABS.
I know everybody's moving on to past the Kapton, but I still like it. It gives you a really nice finish and everything.
Yeah.
But I think I would like to try Hairspray on this. I know that Hairspray is a big one, and the fact that you can take the print bed out and spray it out of the thing is a good. Well, I mean, and since you can take the glass out and the glass is $30 or $40, if you want to have an ABS piece of glass that you put Hairspray on, you want to have a PLA piece of glass you put glue on, or you can just flip them over, I guess. And I love the fact applying. I don't care if it was printer tape or Kapton, of getting it on there and no bubbles and all. That's always a pain.
Yeah.
Or not having each strip overlap too much, and the fact you can take the bed out and just have it sitting there and put it all down is nice.
I kind of want to make a jig that you just put the piece of glass in and lay the tape flat over the glass and then X-Acto it around the edges.
Yeah, so I like that.
Okay, so can we talk speeds and feeds a little bit?
Sure.
The one thing that I noticed immediately about this is that it uses 3mm filament instead of 1.75, which seems 1.75 has become the standard over the last 2 or 3 years.
Definitely.
What 3mm filament's still available? You can get it lots and lots of places. It's on Amazon. It costs about the same.
Yeah.
But why are they using 3mm filament instead of 1.75?
They're using it because they're one of the few that uses a Bowden extruder. And what that means is typically with most of the printers is you have the stepper motor that actually grabs and shoves the filament into the hot end where it melts, is right here. It's mounted on the carriage, right?
That's one of the things in common with almost all of the desktop Fdm printers we've seen.
And you'll notice that the print carriage looks a lot smaller on this compared to some other printers, and that's because the motor and everything is on the back, and we'll get some close-ups of that then so you can see.
So on this one, the bed comes up to the print head and then goes down, right? Okay.
Yeah. So the motor that drives the whole extruder is built onto the back, and so it's basically shoving the filament the whole way from the back of the machine into that. Now, there's good and bad things about that. The good thing is it lets you have a very small, light print head that can move very fast.
Okay.
And it's using much thinner rods and bearings and everything than a lot of other printers because it doesn't need to support a lot of weight.
The neat thing about, you can't see it in our shot, I don't think, but the neat thing about the way all the rods work is that the carriage rod and the rod that drives the gear for the other axis, they're both the same rod.
Yeah.
So it's really simple, really clever design, I think.
It is. Now, the flip side to that is that with the Bowden extruder, they need a thicker filament because you're pushing it, so it needs that thickness to keep the tension.
Oh, so on a traditional extruder, it has a stepper up here, and then it just has to push it through like a finger length to get to the hot end. On this, it's being pushed through this whole tube.
Yeah, it's got a lot more of the push now, which works fine. And I think Ultimaker and Lulzbot are the too few that are still doing that.
Okay.
But they've been doing this from the beginning, and it works for them, and it works well, and that's part of what allows them to get up to such fast print speeds. And it works, so they stuck with it.
So to give context on, let's get a little technical here.
Yeah.
There are a couple of different speeds that matter when you're talking about the printer. The feed rate is the speed at which the heads move.
Yeah.
And the flow rate is the speed at which the filament goes into the extruder or comes out of the extruder. I never can remember. Or I guess you have both. You have two flow rates, right?
I guess it comes out.
Yeah.
I actually don't know for sure either.
Okay.
So
but the upshot is, one is the amount of plastic that's coming out.
Yeah.
The other is how fast the heads move.
Yeah.
This has a much faster feed rate than, say, a $600 printer.
Yeah. So you can do like 90 millimeters per second, no problem.
Okay.
And that's pretty standard for like the higher end stuff. So like say like the Printer Bot Plus, which is their bigger one, I think that maxes out. They recommend a max of 80.
So you can crank the simple metal up to 80. I have found that it works best at about 40 or 50.
Right, and that's the thing. That's where you get on paper. It's like, oh, it can do this. So, for example, this can go up to 300 millimeters per second, which is insane. But you need a really well-tuned one. Like you have to make sure every belt is tight, everything is adjusted.
Probably clamp it to the table, I would think, if it's moving that fast.
So more realistically, I would say you're probably looking at 120 to 150 without too much problem. But I cranked it up to 120 without any problem right out of the box.
So the nice thing about being able to crank up that speed and get good quality is that has a direct correlation to the speed at which it takes your prints to come out.
Exactly.
So faster feed rate equals faster print times, which when you're talking about printing big stuff like the area of this thing can be a significant difference.
Yeah, because you're talking like many hour print. Yeah.
Yeah. So for example, let's talk about some of the stuff you've printed and see like what the print times were, or ballpark if you didn't actually record them.
Yeah.
So these little guys are printed in 3 different resolutions.
Yeah. So this is the Make Magazine robot that they use for This is the Make Magazine robot that they use for all of their tests. Yeah. So there's actually 4 resolutions that you can choose from, like in the quick settings.
Okay.
I didn't get to the finest, but I don't think I even needed to. So we have starting with their fast setting, going to their normal setting, and then the ultra or the fine setting.
So you're not going to be able to. Actually, we're going to zoom in on this.
We'll get a close up of these then.
So you're looking for a bunch of different stuff. You're looking for the height of the vertical lines first, probably, right? Mm-hmm. And then how it handles things like overhangs and gaps and that kind of stuff.
Yeah.
How do you feel? Like how do you feel about? Like, is the draft resolution, the lowest resolution, something you could use to kind of check stuff out, or is it not so hot?
Yeah, I was a little disappointed in the draft. I mean, I know it's a draft, but still, the draft setting is still 0.15 millimeters, which typical normal setting for most printers is 0.2.
Okay.
So you're still falling below the norm. And it turned out a little sloppier than I would have liked. The dome got some gaps and some messiness, but I mean, it's a draft setting.
You can kind of see
it's their draft setting.
You can see the little shimmer that comes out in the pixels there.
Yeah.
Kind of indicates that it's a little linier than you kind of expect today.
So now the normal setting, which is the default. Turned out great. You see a giant step in quality between the two of them.
And this is point 0.1 or 0.8, 0.08?
It's 0.1 is their normal setting.
Okay.
And then the fine setting is 0.06.
So 0.1 is 0.1 millimeters, which is 100 microns.
Yes.
Yeah. Okay.
It always takes me a minute there. Yes.
Some people do microns, some people do tenths of a millimeter. So just to give everybody the information they need.
So it'll go down to 40 microns is the ultra.
That's crazy.
Which I didn't have. The problem is it starts to take a really long time to print then. I think on the fine setting, the robot took like 40 minutes, 45 minutes. The highest setting.
Okay.
So the highest quality one that I did, I think, which is the 0.06 millimeter or 60 micron layer. Mm-hmm. I think that took like 45 minutes.
And this isn't the version of the model with the print and place arms that you can break loose and they'll turn and stuff like that.
No, this is just the static one.
This is the test one.
Yeah, this is just the little static one. And I did the arms up because underneath is like a little test for overhang. So that's basically when you're printing in open air, unsupported geometry.
Right. Sometimes when you print stuff in open air, then you end up with stuff that looks like spaghetti dangling down.
Yeah, and it got a little bit of stuff there, but nothing too bad. Like you can clean it up pretty easily.
And these are all PLA?
Yes, they're all PLA.
Okay, so let's take a look at another piece here, Sean.
Yeah.
This is kind of, first off, this illustrates that the rocker on the bottom, there's no warping on the bottom, which is really nice.
Yes.
Like it's flat.
Yeah.
It seems like it would register nicely with another flat piece that was printed. But it also was a pretty good test of the tower, and then you have some overhang stuff as well going on the inside.
Yeah, so this was printed no support at all. So, I mean, this all turned out really nice.
Is it defaultish settings, or was this after you dialed it in a little bit?
Well, I didn't dial it in, but I did use some custom things. The reason being, because what I'm used to is my MakerBot.
Right.
I have a Thingomatic and I have a 2X, and so I'm just used to like how things turn out on that. I just usually use the default 0.2 millimeter layer settings on that, which turns out great. So as a comparison, I just want a direct comparison. So I set this to 0.2 for this particular.
Okay.
Part. So it's not as fine as the Ultimaker can go, or my MakerBot, but that's what I normally use. So I just wanted a comparison. So it turned out great.
This is a pretty substantial amount of plastic. You printed 2 pieces of this actually at the same time. Do you have any idea how long it took?
I
know we started this one for you because you weren't here that day.
Yeah, I think that one clocked in. Well, this does bring up one small gripe I have about the Ultimaker. The print time estimates seem to not be accurate.
Okay.
And I think what happens is
on the machine or in Cura?
I think in the machine, because I would say that what Cura was estimating generally was pretty good. It usually took a little less time. The machine will keep a running tally of how long it's going to take, but it seems to correspond to how long based on the layer that it's currently drawing. Okay. Which can
So it's doing it's doing based on the number of layers, not based on the linear feet of material.
It seems like that because you would be on one layer and it would be 2 hours, and then the very next layer it would jump to 1 hour. Mm-hmm. So something I don't. So I think that there's a second half to this about the same size, and I think that ran about 15 hours.
Okay.
I'm pretty
So this
sure.
is it's still, this isn't like running a Xerox. It's still going to be a slow process
and
if you
that's
want to
going
make
to
stuff
be
that's
true
big.
and that's going to just be true with any printer, really. And that's going to vary on your. Now this, like I said, this can go to the 0.04. That would drastically increase the print time.
It goes up exponentially the lower the resolution.
Yeah, because you got more layers to
finer the
draw.
resolution.
More layers to draw. And it also corresponds to like how much infill you want to do, like the hexagon infill pattern for strength, you know, how much you want to do.
So can we talk about the software that you use, the slicer? Because this is the other part of this. A lot of people don't realize there's kind of two parts of 3D printing.
Yes.
And the actual printer, I think, is the easy part. The slicing and the software that all the magic happens in the slicer.
Yes.
So Ultimaker uses Cura, which we've used for the printer bot. It's what they ship with a lot of open source printers now.
Yes.
I think it's probably the best free thing that's out there for slicing right now. How did it work with the Ultimaker?
It worked great. It has a very nice interface. Like I said, it has the quick, easy settings, which are. I love that. I mean, I fall somewhere in between. You have like the hot rod tinkerers who just want to like print faster, finer, you know, and they're always just messing with settings.
Yeah.
And then you have the people who are modelers or artists or whatever, and they just want to build stuff and they just want it to work. And I fall somewhere in between. I don't mind tinkering, but a lot of stuff I'm building models and I just need it to print. So I still use the fast, easy settings, and the fast, easy settings work just great, like no problems. Like I said earlier, the advanced tab had a lot of. It had just about anything.
You can get into everything you want to do,
really,
right?
yeah. And now my problem with that in the past, with other software that offers that, is it offers it, but it's like what does this stuff mean?
Are you talking about Replicator G? Because there's a nightmare fuel buried in there.
Yeah, and like what the heck? What's oozebane? I don't know. Like and so I think that they did a pretty good job of like with little bubble, like, you know, tool tips kind of thing of explaining what it is. And I think that that's been getting better across the board, like for a lot of stuff that they are offering the advanced options, but they're also explaining what the heck that means so that it's getting more accessible to your average person.
In my experience, and you correct me if I'm wrong, but it seems like most of the time when you need to dig into advanced options, it's because you've printed something and it's failed.
Yeah.
And you need to dial something back specifically for that print, and then go back to the default settings for the stuff you print in the future.
Exactly.
Okay.
Yeah, exactly.
This works with Octoprint too.
It does. In fact, this goes out to Jeremy. Jeremy was drooling over this when he was in the other day. He was worrying about domestic support and Octoprint, and it does work with Octoprint.
Okay.
I confirm
What
that.
do you mean domestic support?
Because they're based out of the Netherlands, so there was the tech support is like, well, how do I get support if it's out of the Netherlands? And we were talking earlier, the Fabricate, they actually have domestic U.S. support.
I thought you meant his wife complained about the other printer being too loud, which is also a true statement.
Yes. So yes, it does work with Octoprint.
Okay, so what else do you get in the box? They provided a pretty good kit of hardware, right?
Mm-hmm. I was really pleased to see that they sent us extra parts. They sent us a whole extra hot end and thermocoupler, which was awesome.
So I've never broken a thermocouple, but I have clogged up a hot end to the point that I needed to take it off and drill it out.
Yeah.
Which is never a fun experience. Having a spare on hand is really, really nice.
This is great. That was an unexpected perk, which I really appreciated. And I investigated the. It seems like there is a wide, like you could buy just about any part you needed for it.
If a board controller dies or something like that, you can pop that out.
You can buy the motherboard, and I found that the prices were fairly reasonable for most of the stuff as well.
It's really good.
Yeah.
What about on printer control? So it has an SD card. I assume that means that you can run it. You can save your X3G or S3G, whichever it uses, to the card.
It actually just uses G code.
Oh, okay.
Which I also liked.
That's nice.
Because they have moved into like the MakerBot with the proprietary X3G.
Right.
So once that print file is written, you can't really look at it.
Or even if it's just binary.
Read it. Yeah, so for those that don't know, G code was kind of like the default print file that you would get like for a lot of printers.
G code is a language for CNC machines. Like,
Yeah,
everything from 6-axis mills, all the way down to home 3D printers.
Exactly,
use
and
G-code.
you can open it up in Notepad and read like you'll see a line for the temperature and the bed temperature, and it's really easy to tweak things and change it. Once you get into something like X3G, once that's written, it's done. So it's nice that it's just regular G code.
That's really good.
Yeah.
So you can load that up on an SD card, and then you have a menu of things that you can print.
Yeah. So in Cura, first Cura sliced really fast. I was really happy with that. It sliced things quickly. One slight weirdness about it is it's slicing as you go. So if you're manipulating your object on the print bed, like to change the angle or the position or where it's at, it constantly reslices it.
Oh, okay.
Right. So which didn't seem to bog things down or anything, but like that was interesting. I found that they did that.
I find that the slicer in Cura is pretty fast until you have a lot of weird voids and stuff in a printer, and then it sometimes takes a long time in a print.
I did find that to be true. Yeah. But then you can dump it right to SD card if you have it like plugged into your computer or whatever. It has something I appreciated within the program itself. It has a little SD card eject button, which was just a nice little touch.
Does it require something crazy like a 2 gig SD card, or can you use larger than 2 gig SD cards?
That I don't know, because that is true on my MakerBot. So I have this hoard of 4 gigabyte cards, or 2 gigabyte cards. It's like, because you can't,
they're really expensive. They're like $20 for a 2 gig card.
So you got to keep those like gold. Yeah. I don't know on that. I believe that the card it came with was 4 gigs.
4 gigs, that's promising.
So, yeah. So I can't answer that. But the controls are great. It has this little jog wheel.
Okay.
And it's just a turn and click, press to click. You can access pretty much all the features right here on the printer. It has like, you can control anything from the lighting to how bright they are to...
Okay. Are they RGB or are they just all white?
I think they're just all white.
Okay.
I haven't played with that
looks
enough,
like
I don't know.
So
the scroll wheel works pretty good. It has advanced and basic things. So there's just, if you go to like the main menu.
And is the scroll wheel clicky?
It is.
You select by clicking in?
Yep. Okay. It's clicky scrolling, and then you click, press the.
Got it.
Yeah.
Well, that's really fast.
And so you get into the basic menu is just.
So how does it automatically level the build plate, or do you have to?
No, it's got the
manually?
3-point screw spring combo,
Similar to the MakerBot.
Yeah, but it was relatively fast and easy. I did it once and I haven't done it again.
Oh, that's always good.
Yeah,
you've taken the glass off.
It seems to be a really rigid platform.
Is it metal arms? It's a metal base.
Yeah, it's a whole metal base, really heavy duty metal in the back, and then the glass.
Okay.
So it has lots of nice features on the machine itself. Some of which I really liked was I did have a few jams. Happens.
Okay.
So for loading, like I will say on my MakerBot or similar printers, it just has a little spring-loaded release that you can pull it down and pull out the filament, which I kind of love. This is a little more complicated because of the tube setup. You have to feed it into the back, and then it's all automated. So it has one step that it runs it really slow, and it grabs the filament. It's like, do I have the filament now? Yes. And then it goes really fast and feeds it in there, and then it goes slower. So it's not as straightforward to load it. So I had a few problems where it jammed when I loaded.
Okay.
But it has a nice feature in the menu, in the maintenance section called Move, where you can basically pull that up, and then the faster you turn the scroll wheel, the faster the filament will go. So you can go really slow clicks on it, and it will just creep the filament into the hot end or out if you go the opposite direction. Or you can really turn the jog wheel and it'll go faster. So that was nice. That was a good troubleshooting thing.
What happens if you mess up and run the last of your filament in? Can you break this down and pull it out take the tube off?
Yes, there's little clips here that are on the tube that you can pull off, and then you can just easily pull the tube out.
Okay.
So that's relatively easy. I did have a little piece break off and jam in the back extruder, and it's somewhat open back there, and I was able to get it out with tweezers without disassembling anything.
Oh, that's definitely easier.
Now, but with being open source and still, I think the nature of 3D printing, there's a lot of modders out there. So there's, of course, the improved extruder that you can download from Umagine, which is their version of Thingiverse, where they have all their, you can download stuff. So from Umagine, you can download the improved version 2 filament extruder and print it and install it.
Okay.
And it's more open, and you can get the things easier. And apparently, it's better if you want to print flexible material like Ninja Flex or something.
Okay.
So there is that as well.
Cool. I think you answered all my questions, Sean. So, I mean, this seems like a really awesome step up compared to, say, a $500 to $1,000 printer. Mm-hmm. Especially if you're getting into a situation where you're using this for work or something where time matters.
Yes.
But if you're just a home hobbyist and you want to start out, stick with something inexpensive like a printer brought Simple Metal or one of the Cube printers or something like that.
Yeah.
Or the Dremel even for a grand.
The printer bot is great. I still encourage. I think building a kit is a great idea. It really gives you a better knowledge of how it all works.
It's like building a lightsaber.
And they still have their kits, which is great. And I think their kits run like around $1,200 or something like that. So
that's a fine place to do the first round of upgrades.
Yes.
Anything you don't like about this in particular? We talked about print time estimates. We talked about the 3mm filament.
Yeah.
Is the availability of 3mm filament, like, can you get all the crazy flex filaments and the stuff with the metal and the wood and all that in it?
Yes.
At 3mm?
And I was a little concerned. I have a little bit of a bias because most printers, as we discussed, are using the 1.75 millimeter. Mm-hmm. So I was like 3, and my problem is that everything, I have a crate of 1.75 millimeter.
Yeah.
The only thing that would hold me back from getting this is the 3. I'd have to switch over all my filament.
Yeah.
So if you're an established printer, that's a little bit of a, but if you're buying something new, it makes no difference.
Okay.
I looked into it, and I think you get a slightly better selection of 1.75, but there's tons of 3 out there. It's the same price per kilogram as the other stuff. And as of right now, it seems like that there's a fine selection. Now, the one thing that I did find you need to be careful is they call it 3, but it's actually more like 2.85.
Oh, okay.
And what I found out was that there is true 3mm filament, and you can run into problems.
Like you'll have too much plastic going in?
Well, it can jam in the tube itself, the Bowden tube here. It can jam into, and it can be it can put a strain on the motor, and you can get jams.
Okay.
So, but I think it seems across the board, like if you go to like your typical filament place or Ultimaker itself or whatever,
or Amazon,
it's going to be 2.85. But that's just something to watch out for. But other than that, no. And
I mean, one of the things I found printing is that the best way to improve your print quality is to take your calipers and kind of measure 10 or 12 times at different places on the filament.
That really does make a difference.
And it makes a huge improvement. So you should do that anyway.
Yeah.
And you'll find out quickly if you accidentally bought 3mm instead of 2.85.
So that's not, I can't say that's a negative. That's just something to think about, especially if you're coming from another printer.
If you have a few $100s worth of 1.75mm filament laying around.
Other than that, I mean,
sorry, filament though, just if people don't know, figure around $30 for a kilogram, which is one of those big spools.
I would say estimate more like 40 to 45 because it depends what you get. Like if you get into more like some of the really pretty like translucent ones, it can get more closer to 45 or something. And
if you get stuff that's cheap, then it can vary in diameter, or it can have too much water or something like that. It makes it hard to print.
If it's the old adage, if it's too good to be, if it sounds too good to be true, it probably is. So if you're like finding this a ridiculously cheap filament, it's probably junk. So,
your mileage. I mean, take the chance. The worst you're out is $25.
I've done it. It's bit me in the butt a few times. Yeah. So.
There's a couple other models that they offer.
Yes.
So they have a kit for $1,300. You said.
Yes, I believe that is. I think it's $1,100 to $1,200. Yes.
But plus all the normal shipping internationally and all that stuff.
You can actually. The kit is $1,300.
Is this
right off of like Maker Shed or something?
This is a big enough platform to do like a helmet if you have a small head, or at least front and back.
I think you can do it. It's a very generous print bed. Yeah. The kit is $1,300. That is the original Plus, which does come with a heated print bed, which is nice.
Is it wood and a glass bed as well?
It's the good old wood, but I think it's upgraded to a glass print bed.
Okay.
And then they have the Go, which is about half the print volume and is PLA only because it's not a heated print bed.
Okay.
And that's running $1,300.
Okay.
And then they have the Extended, which adds 4 inches to the height. Same dimensions other than the height. You get 4 more inches on the height, and that's $3,000. So I mean, the only reason I can see to spend that extra money is if you knew that the things you were going to print are going to be.
If you want to make armor and you need something that's as long as your thigh, you need it for the 4 inches.
In that case, you might be worth investing in the extra money. But other than that, it's identical to the two here. Well,
cool. Thank you so much, Sean. You have a regular column where you talk about 3D printing on the site.
Yes.
So if you want to know more about 3D printing, it's a great place to start. And you go through all the kind of technical.
And we'll probably be doing a write-up on the 2 as well to get into a little more nitty-gritty. So
sounds good.
Yeah.
And we will have more on Tested real soon. Thank you guys for watching. If you like the video, subscribe to the channel. We'll see you all next time.
Thanks.
Bye.